Hello everyone, this is Bradley. Today's topic is this infinitely loopable circling around animation. To keep the background story short, I would say that if you have watched my live noding, just 1 minute or so, you will realize that I actually have a huge debate with myself about the method to approach this problem. Even within the live noding, I was switching back and forth about different methods. And I finally said that take one is the method that I'm going to use. But yesterday, when I was looking at my animation, I changed my mind again, modified the tree and reposted this animation with almost a method between take one and take two. You don't necessarily to understand what's the strategy of take one and take two respectively for now. But at some point they may be important and this will be mentioned in the future. Today, however, I will use the method which I think the newest and the best to work with this animation. I will do the tutorial with the preset library because it will make my life easier. You can download the preset library from the link in the description, and I will use the same startup file as available from the preset library. Also, I will do a separate tutorial not using the presets, but it may take a little bit more time. Whatever, let's start. So firstly, let's discuss the most basic principle of this entire animation. Basically, the whole point is that I'm going to generate a circular path and I have a cube. So let's shrink its size. I'm asking this cube to follow this path, basically fly with it. And this is basically all about it. The next thing I need to do is basically just to duplicate one more path, having another cube to fly with it. And one more pass, another cube, one more pass, another cube. And the rest thing is basically just to add additional feature on the top of this principle. For example, add the variation of all these cubes. Some cubes are larger, some cubes are smaller, and add the variation to the circle as well. Like adding different turbulence, different sides of paths, different direction or whatever stuff that you can potentially think about. So in short, the basic principle is super easy. Just think that in an easy way, I just need a circle and a cube and make the cube to follow that. So this is where we are going to start with. So how to do that exactly with the preset? So to generate a circle, I'm going to add a distributed matrices. I'm going to change the type into a circle. And if you take a look with the 3D view, then we're generating 10 vertices of the circle. And next thing we need to do is basically form it as a spline, which will form as a path. So this is the spline formation node. And we're going to make it cyclic. And to get a sample, we are going to have a curve object output. This step is not necessary. This is just to look at the spline that we are actually generating. This is just for visualization. And because it does not have thickness, so it probably will not be rendered at all. It's just for kind of guidance. Make sure, I'm really generating a circle. This is basically it. And then we're going to use another preset, which is called follow spline. So in this follow spline node, it will actually generate a matrices. What we need to do next is basically just the object matrix output and select our cubes. And by changing this parameter, then we just have our cubes flying on the spline. So this is not a very difficult, just 4 nodes, you get something to work. Next thing is basically just to add additional feature of this entire whole things. Also, one thing to realize, if I turn off this loop, then this circle, this cube will just stop at 1 because the parameter essentially is a value between 0 and 1. So unless you take on the loop, otherwise it will not be looping. Very straightforward. So the next question is, how can I actually duplicate this spline? And that turns to be the point. The next thing that I'm going to do is to instance this circle. Instance this circular path. I'm going to use a method which is probably a little bit different from your thinking. So here I'm going to take a loop input and I'm going to put these amounts back into the parameter. And make sure that you don't put the amount into iterator because we need to put something else into the iterator. So I'm going to select this blue loop and hit W goes to write to invoke a subprogram. So you can see there is an iteration and amount. So if I'm going to put iteration to 1, this loop will be run for once. So it's actually creating the circle. And then if I'm changing the amount, you can see there's nothing changed unless you put the amount to 2. Because the whole point of this distributed matrices is it actually it creates a lot of points and use the spline formation node to connect all these points and finally generate a circular path. So I'm going to name this amount into resolution. And as you see earlier, if I increase the resolution to very high, it does not actually make too much difference because it's already a smooth circle with the smoothness for 30% or whatever. So I generally would just keep this resolution as 10, but you can increase that or decrease that. It will have some effect later, but not now. And the iteration will determine how many circles you created. So even now you do not see any difference, but it's actually 22 circular paths in total. Okay. And in this iterator, I'm going to change that into matrices or a matrix list. So now the iteration has been gone, but instead we have a matrix list. I'm going to input a matrix list. So let's take a distributed matrices and put this Z into an amount, maybe for 5. So now it's which means this loop is supposed to be run 5 times, but we do not see anything. The next thing is going to separate these splines using this matrix data. I'm going to use a node which is called transform spline. Put the spline into the socket and the matrix into the transformation. So you can see the orange goes to orange and still nothing occurs. This is because there are multiple reasons of this entire whole thing, but I'm going to basically hit this plus icon and output this spline. And then I'm going to cut out this entire node and hit E to select the dependent node. Actually, hit E and select the dependency. No, probably I will just drag and select all these nodes. And then put this spline list into this reroute. So instantaneously, you can see there are 5 circular paths being generated according to these matrices. So if I increase the height, then it has been increasing the height. I can increase the amount, then I have more circular paths. So this is the first step. The second step that I'm going to do is to instance the cube. Firstly, I want you to be aware that this follow spline node does not receive multiple inputs. It outputs the blue loop output a spline list, but the follow spline only receive a single spline, so the plural does not go to the singular. Here what we're going to do is select this blue loop and I'm going to hit W, goes to the right and loop through the spline list. And now within this green loop, I'm going to put the spline to the spline, so the singular to singular. And now we start to see something happens, but we still only have 1 cube. What I'm going to do here is to hit this plus icon and output the matrix list. And put the evaluation to the matrix. And finally, I'm going to put the matrix list into matrix list. At this moment, you don't see anything immediately happen, but I'm going to instance this cube using the object instancer and put the matrix list into the instances and objects into objects. By selecting the cubes, now we have instanced the cube. So we instanced both the circular paths and the cubes, and by using the same parameter, we are actually changing everything. Except for our mother cubes. So let's just move the mother cubes back to the origin. So now we have 5 circular paths and 5 cubes looping around. And this is basically the animation, which is the most basic form of our animation. Which involves probably 2 subprograms and these many nodes in total. So starting from now, we're going to make the entire thing more and more complicated. Firstly, I want you to take a look with this part. And I have matrices and a blue loop, and I'm going to rename that as a circular path so that you can best identify the meaning of the functionality of this blue loop. So I want you to be aware that these distributed matrices is actually controlling all these circular paths. So assuming these all circular paths are already a single object by its own, the matrices is basically the determining the transformation data of each circles. So if I have 20 matrices, then I have 20 circles. I can also change the height of these circles. Another thing that you can potentially do is to enable this Z. So this Z option means to offset. So everything will be centered at the water origin once you enable that, and it will move the circle to be offset as well. Which also means that if I try to change these matrices, then this circle will also be changed. And let's show you exactly what it means. So I'm going to use the offset matrices, and I'm going to enable the rotation and the scale. So if I decrease scale on x-axis, you can see all this circle has been shrink down x-axis, but not affecting the other. Which also means if I change the x, y, z at the same times and scale them down, then the circular path will be shrinked as well. So the rest that we need to do is just to add the variation of all these scales. And I'm going to use a preset which is called the minimum and the maximum. And I'm going to use the list because I'm going to generate multiple numbers. So I'm going to put these matrices into the iteration so that I get a numbers which links. So if I have 20 matrices, then it will generate 20 random number. And then let's explain a little bit about this node. This node is that it will generate a minimum and maximum value. So this node has several options. For example, I only want you to be aware of this base and the percentage range in addition to seed. So if I have a base, then minimum and the maximum are both 1. Okay. However, if I change the percentage range maybe to 20%, then the minimum value is 0.8, the maximum value is 1.2. What does that actually mean? Is that it will actually generate a number between this range, and this turns out to be the value. So we have a value of 0.951, 0.86, and so on and so forth. All of them must be in the range from the 0.8 to 1.2. And if with this value there is a node which is called a vector form value, which convert these values to uniform scales. For example, 0.95 repeated several times, and that's the option that finally turns out to be this size. Which means if I just put these sides, then I'm changing the scale of all these matrices, and immediately I'm changing the scale of all these circles. And you can try to increase the variances so that different circle has been generated, and you can also decrease the z divisions so that only these circles being generated. And by changing these base sides, then everything has been scaled down. But if you just change the percentage range, then it just adds more variance. You can also change the seed so that different seed has been generated and so on and so forth. So this is one part. This node will actually be run many different times. So this is one part of it. The next thing that I'm going to do is to add a little bit of tilting of all these circular paths, because now they are kind of so boring. Everything is on the XY plane, absolutely correct. So I don't like it, so I would like to add a little bit of tilting. To do that is actually very easy. You just add a random CUDA. and generate a list by hitting this icon. Turn that to blue and use the get list length to the count. So we generate a different rotation for each of them. And you can directly put these rulers into the rotation and it will generate whatever tilting right away. However, here's one thing, that's I rotate on every axis, but I don't want to rotate that on the axis because it will actually offset the cubes. This will be done later. So personally speaking, I don't want this to happen right now. So I'm going to use a ruler math and set a multiply. And every XY axis will multiply to 1, so there's no change, but I'm going to multiply 0 to the axis so that everything has now been aligned to the same place because there's no rotation on the axis, only XY. Okay. Everything essentially are optional and it depends on your design, and you can change the scale. If you change the scale too much, it becomes very weird. I don't know, something abstract. Actually, it looks kind of very interesting to me. But this is not the topic today. So you can change whatever values that you feel very like. I think this is good enough. At least not making that too boring. Okay. Next step is to actually generate kind of turbulence to all these kind of circular paths to make it not very uniform. So, and this is where we are going to focus on this entire blue loop. So the question is how to actually add some turbulence to this entire whole thing. How are we going to do that? I'm going to add a vector mass. It's actually very simple. It's basically just adding kind of noise to each of these vectors. So now these vectors are perfect circles, but if I add any kind of turbulence and connect them to form a spline, then it will be kind of more kind of wavy path. And here I'm going to use the vector wiggle. Of course, you can also use the random vector. It does not really matter which one you actually use. Personally speaking, it might be better if you have more detailed control in amplitude, but it does not actually really matter, does it? So I'm going to hit this icon to generate a list. So that's for each vertices, I'm going to generate a random number. I'm going to use the vector form value to control x, y, z separately. So probably it might be better if we just use the random wiggle. I don't know. It does not really matter to me. It really doesn't. But anyway, so let's take this vector wiggle. So immediately we can see a lot of noise has been added to our patterns, and it looks kind of nice. You just decrease it so that maybe the noise has just a little bit in touch. Should be enough. Yeah, I think it's kind of nice. One thing you will realize is that each circular path is the same, and they have been added with the same noise, with the same seed all the time. That's why they are actually the same path, just being tilted differently because we tilt it differently. So how to actually fix this issue? There is another preset which is called index seed. This index seed actually only contains 2 nodes at this moment. Basically 2 float mass nodes. What it does is you put an index into place. So basically talking about kind of principles. If I'm generating the index goes from 0, and it will go 0, 1, 2, 3, 4, and continue until the last iteration, basically. And if you just directly add a seed, for example, my seed will add to 1, then it will generate a seed of 1, 2, 3, 4. And it will cause a problem that many of the numbers are actually overlapping, which make the seed not like a seed, because finally only one number one seed will be changed if you simply just adding the seed to 1. Okay, it will not causing a dramatic change. So instead of using the addition, like +1 method, I'm going to use the times method. So that if I times 2, then it will becomes 2, 4, 6 whatever stuff, then this seed will be changed very dramatically. But you again realize a problem that the index starts from 0. 0 times anything is still 0. So that's why I have an offset that just make the 0 not 0. So this is almost the whole principle of this entire preset. It's just to make your life easier instead of just generate 2 float mass, duplicate the float mass, and do other things. It's actually very straightforward. So just put this integer into the seed. Then immediately you get different seed, and by changing these seed values, you really change dramatically different seed. And I'm going to put this seed back into the parameter so that we can control within the loop instead of going to this whatever node tree. I'm not going to care about the offset because it does not really matter. They essentially do the same thing. And I'm going to put this factor value to the parameter as well. So only basically put the values which are you think is very important to change back to the parameter, otherwise you don't. You probably will realize that I do not put this radius back to the parameter. Why? The reason is that because you can control all these circles size using this base value. So by the end of the day, they do the same thing. That's why I only use base instead of using this one, because the base and the variation are linked together. But for this one, it's probably not. I mean, for this one, probably not. So yeah, whatever. And for this part, it's basically done. So now we have interesting circular path. Actually, this is already done. The next thing is basically to add a variation of our cubes, and it's more kind of easy to do essentially. So the first thing that I'm going to do is put this parameter back to the parameter. This sounds to be a joke though, but I'm serious. So put that into parameter. But the parameter is not a very clear term. It's not very informative. So you can change its naming. I probably will just name that as position. So the whole point of this position is that if by changing this position, then the cube is floating. And here's one very important point I want to remind you, that if the position goes to 1, then it's not a change because it looped for the entire full term. Okay, so this is very, very, very important. And the next thing is we're going to add some offset. So how to add offset? I'm going to add a random value to each of the parameters to add the offset. And by saying random number, you probably realize we're going to use the index seed. So index goes to loop index, and the seed goes to parameter. And you can change this offset to whatever values. And here I'm going to again use the minimum and the max, but this time I'm going to use the loop version instead of the list version. The reason is because the loop version is used within the loop. And let's name this loop as a cube. Okay. I'm going to put the seed into the seed. So, and here I'm going to, so firstly let's add a float mass and use the addition. Here I'm going to turn off this base and use the absolute range. So what it happens is if the base goes to 0 and without turning on the absolute range, so no matter how you actually turn on this percentage range, the minimum and the maximum will not change, is because everything times with the base, which is 0, equals to 0. So you have to use the absolute range so that it will generate a minimum and maximum value from -1 to 1, something like that. Basically this is where's y? Yeah, basically this is it. So here I'm going to just use this random value to add to the original parameter. So you can see everything has been offset from 0. So some of the points goes forward, some of the points goes backwards. So this is a kind of interesting offset. So you can just change whatever values and be aware they retain the ability of loop at 1. So if you change the position to 1, they do not move. But if it's the value between 0 and 1, they will move. So you can just play around with that. This is almost a trick of the infinite loopability of this animation. And you can decide this range to be larger and shorter. And because it's important, so I'm going to put only this percentage range back to the range. Here, there's another thing that's just a kind of optional thing to do. I'm going to duplicate this float mask and add a multiply. And duplicate this minimum and maximum loop. Duplicate a index seed. Put the index into index, seed into seed. So if the offset is the same value, they actually generate the same number seed. I don't want that to happen, so I'm just going to change these offset to whatever other numbers. So it will generate a different random number. I'm going to turn off this absolute range, keep the base to 1, and put this value to the multiply. So right now, there's nothing happens for real, because there's no variation into this base number. So every parameter has been times to 1. There's no change. It's not supposed to have changes. So another question is why I'm actually times everything with 1. It's because if I add just a little bit of variation, immediately you do not see too much of the difference. However, it's actually the difference of speed. So if I put so if I go to position and time a time info series node, I will explain this node a little bit later, but first, now you just need to put the times into the position. So if I keep the variance to 0, then we'll just run at such a speed. Okay. If I keep the base to 0, then they don't have a speed to move at all. And if I keep both the base at 1 but add a little bit of variation, then what you can see is some of the cube will actually run faster. So let's keep the base size a little bit small. You can see some of the cube will actually run faster, and some of the cube will run very slow. So for example, initially you can see they start from almost the same point, but if I increase the range of time, then you can see some of the points, finally it generates kind of difference. Some of the cubes are run much faster than the other cubes. And if you keep this variation to 0, they still looking almost at the same line. So this is almost like kind of whatever, this is almost like this kind of situation. Which also tells one thing, that if you try to make this animation infinitely loopable, then you probably don't want to use the seconds minimum and the maximum. By the end of the day, this is a speed offset. So here I'm going to put the percentage range back and name it as a percentage speed offset. If you want your animation to be infinitely loopable, then you don't want to have this speed offset. It will still loop, but it will take probably 1 billion years to loop. It's too hard to actually know at which exact point it will actually loop, so you'd rather not use that. But if you don't care about the looping, I would recommend you to use this function. For example, the bird is flying on the skies, fish is swimming in the oceans. Then it will make the animation much more interesting instead of just looping over and over again here. Okay, this is just kind of idea. it's optional. So this part of the path has been basically almost completed. The next thing is basically just talking about the random scale of the object. Basically, that's all about it. The last thing that we need to do is basically just to add a random scale to all these cubes, and it's fairly very simple. I'm going to use these transformation sockets. If you have watched a tutorial that has used to build this for spinal, you will know this transformation socket is for individual transformation of all these cubes. So here, because it's a random scale of cubes, I suppose you do realize about what we are going to do. It's again very straightforward that we're going to use the minimum and the maximum loop. And because we're going to generate another seed, so probably duplicate this index seed again. This is almost half of the reason that I created this seed, because you do realize the fact, I hope you do realize the fact that in reality this actually contains two nodes, two float mass. So if you don't have this preset, instead of having 3 duplicates, you will have actually 6 duplicates in total, which is actually fairly horrible to achieve such kind of function. But of course, if you are not using the preset, probably you are also having the ability to change the seed. No, actually probably no. So a lot of problems that will actually occur. So that's why I created this seed. I also do realize it's probably one seed output is not enough. Probably you would like to create more seed outputs with different values. So that's under consideration. But here I'm just going to add different. So base size is 1 and variance whatever. So I'm going to put both of them back to the parameter. And here I'm going to use a scale matrix. Put the various size into the scale, put the matrices in the matrices, and immediately you have a random size. And based on your, so let's rename it as a size percentage range. And put the size base. I know it's kind of not grammatically correct, but I want to emphasize the point of size so that you know, oh, this value actually controls size. So if you increase the percentage range, then there's more variance. And basically this is it. So there's another thing that you can also add random rotation or Euler wiggle. It's possible that you put a Euler wiggle to the place, and you can just use whatever seed into the seeds. And evolutions add amplitude. And so on and so forth. Just to be aware that if you are going to change this evolution for real, if you're going to change this evolution, then it will animate that. But this evolution is not inheritedly loopable. So there are multiple different ways to loop this entire whole thing. For example, probably the easiest method, one of the method is basically, there are actually many different ways to loop this evolution. Maybe just a keyframe that's 0, 1, and back to 0. Just this is basic idea. Whether you keyframe that intentionally, or you use a sine wave function, or whatever things you're going to do, just be aware that if you're going to animate this evolution, just you need to go back and forth. You need to go back to a value and finally go back to the value. This is something that you must do if you're using this evolution. Otherwise, this is already a random rotation and it's already basically done. And we are animating this entire whole thing. Okay, let's talk about this time info series. Actually, this time info series, there's a lot of things that you don't necessarily worry about. Basically, for the delay and the looping rates, you don't necessarily care about them, just forget about them. You only need to care about there's a rate factor. There is a rate factor, which is actually division. if you turn on this multiply, that means it's multiplied number and it will be moving extremely fast. Otherwise, just a divide number so that it runs slowly. You can divide it by 5 so that they run equally fast. And basically, this is all about it. I hope this tutorial is not actually overwhelming, even if it's actually using a lot of presets. In fact, if it's not using preset, it will probably be very horrible to really think about. Because even you shorten usage of nodes, it's this many nodes. Otherwise, it'll probably make life suffer. For example, just the index CD is already 2 nodes. So I have 6 nodes here and 2 nodes here and more nodes, many different places. So on and so forth. I think this is all about it. Oh, another thing is instancing. There are multiple ways to instance an object. The object instancer is actually not the only way. There's another method which is called instancing object. There's also a method, and if you're interested in the difference between the object instancer and instancing object, these 2 nodes, you can take a look with the tutorial, which is free. If you would like to know about the instance random instancing from a collection, then you can buy the file on Gumroad. Basically, it's about it. So I think this is kind of a nice setup because you can instance a lot of cubes. So even like 400 cubes, it's still with kind of acceptable performance, which is much below the 500 milliseconds. So you can just play around with this entire thing. Another good part is that you can potentially see your paths so that you can change your value accordingly. For example, if I increase the values, then it becomes very horrible. Kind of noodles, whatever. I don't know what I'm actually looking at, but this is all about it. And you can change the seeds as you wish, doing whatever crazy things is you want. So I hope you enjoyed this tutorial, and I'll probably see you next time. Bye bye.